Hello friends, in today's class we are going to see what is electromagnetic flow meter. So the operation of this electromagnetic flow meter, it is also called as mag flow meter. It depends on the Faraday's law of electromagnetic induction. So the operation of electromagnetic flow meter or mag flow meter works on the principle of Faraday's law of electromagnetic induction. So the Faraday's law of electromagnetic induction states that the voltage induced across a conductor as it moves at right angles through the magnetic field is proportional to the velocity of the conductor. So the operation of this electromagnetic flow meter depends on Faraday's law of electromagnetic induction, which states that the voltage induced across a conductor when it moves at right angles to the magnetic field is proportional to the velocity of the conductor. So we can write the equation for the voltage induced or voltage generated in the conductor is directly proportional to the velocity of the conductor, that is the fluid flow here. So electromagnetic flow meter, here it is used to measure the flow rate of the fluid into the magnetic field strength in the across the conductor, and d, which is the distance between the electrodes, or the d represents the diameter of the pipe. So E represents the voltage generated in a conductor, the voltage induced across a conductor when it moves at right angles to the magnetic field will be proportional to the velocity of conductor. So velocity of conductor is nothing but the velocity of fluid, and here B represents the magnetic field strength and D represents the distance between the electrodes, or represents the diameter of the pipe where the fluid flows. So E will be directly proportional to V into B into. Now let us see the diagram for the electromagnetic flow meter. So electromagnetic flow meter has a electromagnet which is produced by energizing the core. Around the core, coil will be wound, will be energized with the help of a DC supply. This core acts as a electromagnet. So when the coil is energized with the help of DC supply, the core acts as electromagnet, developing north and south poles. So in between the magnetic field of this electromagnet, the pipe which carries the fluid whose flow is to be measured is kept. This shows the cross-sectional view of this pipe, and at the external ends of the pipe an electrode will be connected, which is used to measure the output voltage. The electrodes are connected here, and the electrode will be connected to a meter. And this pipe will be placed in the magnetic field of this electromagnet, and the direction of flow rate will be perpendicular to the magnetic field produced by this coil. This represents the fluid flow, and these are the electrodes which is used to measure the output. So this electromagnetic flow meter, it consists of a insulated non-conducting non-magnetic pipe carrying the conductive fluid whose flow is to be measured. So this electromagnetic flow meter consists of pair of electrodes connected in the opposite sides of the non-conducting non-magnetic pipe is carrying the conductive liquid whose flow is to be measured. So it has a pair of electrodes which is placed on both the sides of this non-conducting non-magnetic type pipe which carries the fluid which is a conductive fluid whose flow is to be measured. And also this pipe is surrounded by a electromagnet which is created with the help of a DC supply which produces the necessary magnetic field which flows along the pipe. So the pipe is surrounded by electromagnet which produces the magnetic field. So it is analogous, this pipe is analogous to a conductor moving across a magnetic field. So we know that the fluid moves along the longitudinal axis of the flow meter, that is the flow meter, the longitudinal axis the fluid flows, and the flow of this conductive liquid in the pipe is perpendicular to the magnetic field produced by this permanent, that is electromagnet. So the sensor or the voltage signal will be sensed by these electrodes located on the sides of the or walls of this pipe, and this electrodes will be perpendicular both the magnetic field and the fluid flow direction. Okay, so the magnetic field will be produced with the help of this electromagnet, and the pipe which is carrying the conductive fluid is placed in this magnetic field, and the flow will be perpendicular to the magnetic field which causes a voltage to be sensed by this electrode, and it can be measured with the help of a meter. So the magnitude of voltage appearing across these electrodes, this plus and minus, will be directly proportional to the velocity of flow. So we can say that the magnitude of voltage appearing across the electrode will be directly proportional to the velocity of liquid flow. So increase in the flow rate will increase the voltage across this electrodes. So here we are using a non-conductive pipes because as the output voltage gets short circuited if you use a conducting pipe or metallic pipes in case when the fluid has low conductivity. The fluid which has low conductivity is to be measured, or the flow rate of the liquid whose conductivity is very low is to be measured. We have to use a non-conducting pipe, because if you use a conducting pipe means what happens, a short circuit will happen in case of liquid having low conductivity, but it is not so in case if the conducting fluid has high conductivity, that short circuit effect will not be considered. So steel pipes can be used when conducting liquid has a high conductivity. So voltage produced is very small if the flow rate is low. If the rate of flow of the liquid is very low means the voltage produced will be very low. So we need a amplifier to convert the induced voltage into a usable form. So if the flow rate is high means proportionally or linearly the voltage will be high. Now let us see the advantages of electromagnetic flow meter. Though here the obstruction So the flow is almost nil. So therefore it can be used for measuring heavy suspensions including mud, sewage and wood pulp. So the obstruction flow is almost nil in case of this electromagnetic flow meter. So it can be used for measuring the flow rate of conductive liquid having mud, sewage and wood pulp. The second one is capable of handling extremely low flows. Even a very flow rate of conductive liquid can be easily measured by using this electromagnetic flow meter. Third one, the output, that is the voltage, is linearly related to the input, that is the flow rate. Output voltage is directly proportional to B into V into D. So the output voltage V is directly proportional to the flow rate or the velocity of flow, that is V. So it has a linear relationship with each other and they are practically unaffected by variation in the characteristics of liquids such as temperature, pressure, viscosity and density. So the various characteristics of liquid like temperature, pressure, viscosity and density will not affect the output of this flow meter. Next one is electric power requirement is low. That is 15 to 20 watt is enough for, that is pulsed DC type is enough for this operation of this meter. It can also be used as bidirectional meters. And it is most suitable for acids, bases, water, the aqueous solution, because the lining metals used in the pipe is not only a good electrical insulators but also a corrosion resistance material. So it is more suitable for acids, bases, waters and aqueous solution. So the material used is corrosion resistance. It can be used for acids, bases or any aqueous solutions. Next, let us see the limitations of flow meter. So it can be used only for fluids which have reasonable electrical conductivity. So if the fluid has only reasonable electrical conductivity, it can be used. Second one is it can be used for flow measurement of waste water or dirty liquids like slurries, sludges or any conducting liquid. So it can be used only for fluids which has reasonable electrical conductivity, and can be used for the flow measure of wastewaters like slurry, sludges or any conducting liquid. So it is an application of electromagnetic flow meter. Thank you.